In this video, we'll be looking into WAEC 2025 Physics Practical Prep. So this is the alternative B, and this is the specimen for question number 1. As you can see, the specimen, a G climb, a metal roll, spiral spring, Retort stand with a climb, masses of 150 gram, 200 gram, 250, 300, 350, Sellotape, and Stopwatch. So looking at it, this is Hooke's law and the motion of what? Of spring mass system. Now let's go to my likely predicted question for you to see. Now, this is the likely WAEC 2025 Physics Practical Prep for alternative B for the question number 1, which is mechanism. So you can look at the question very well. A says you set up the apparatus. So B now says you should suspend the spring vertically from the Retort stand using the climb and G climb. Attach the metal rule vertically beside it with sellotape to measure the spring's extension. C says without adding any mass, record the initial position at the pointer on the spring that is on stretch length. So then D says you should add 150 gram of the spring and record the new readings on the metal rule. Then measure and record the extension. So E says you should repeat the procedure for 200 gram, 250, 300, 350. That makes it 4 grams and 5 grams like that, because 150 is starting here. Then take it to 200, 250, 300, 350. So this one, F says I should tabulate your results to include the mass in gram, the weight in Newton, extension in cm cube. Then use your G as 10 meters per second. So then G says you should plot a graph of weight N, that's the Newton, on the vertical axis, and extension cm cube, centimeter, on the horizontal axis. And then the next question now says that you should determine the slope of the graph and state its physical means. Then the last question says that what is the significance of the straight line nature of the graph. So that is my predicted questions from this particular specimen that WAEC give for this 2025 Physics Practical Alternative B. As you can see, the specimen. Okay, so now let's go to the, after carrying out this procedure, all these procedures I have here, so I was able to come out with a table, and then this is the table. So I have the table here. So this is the readings. So like I do say many times in my video, that my table is just, this is a likely question, so my table, they are just there for you as a guide. So anything you watch on this video is just there for you to have the guide of, like, to have the likely things that you might come across in the live question. So this is not a live question, this is just a likely or predicted questions that you must have or you must know. Again, this is the specimen, as you can see. Then this is my likely questions for WAEC 2025 Physics Practical Alternative B, question number 1. As you can see it clearly here. And then this is my readings. So this is my readings. So now from the from this question here, they said repeat the procedure for 200 gram, 250 gram, 300 gram, and 350 gram. So I have it here. I repeated it. Like I said earlier, I said the masses is going to be in 5 grams. 1, 2, 3, 4, and this 150, making what? Making 5. So now I have the readings here. The mass 150, 200 gram, 250, 300, 350. Then the weight, that's in Newton, 1.50, 2.00, 2.53, and so on. Then the final readings in cm cube, I have this. Then the extension in cm cube, I have this. So here now says assuming your stretch length is 34.00 cm cube. So as you can see it here, as you can see it from this C, they said without adding any mass, record the initial position at the pointer on the spring, that is the unstretched length. So then we have the unstretched length here as 34.00 centimeter. So now the next question here, after I've repeated the procedure, Then the next question here is to tabulate your results to include this, that, and this. This is mass, weight, extension, which I've done that. As you can see it here, I've done that here. Then the next question I have here is now, you should now plot a graph of weight n on the vertical axis and extension on the horizontal axis. So now this is just a likely question, like I've said earlier. So they are not the real or the actual question. But this specimen I have here is the real and live specimen for alternative B that you should know. So let's go to the next question, which is question G, which says that we should plot a graph of weight n. Plot a graph of weight n, that means that's the Newton, on the vertical axis and the extension of cm on the horizontal axis. So from this table here, I'll be plotting from here. From this table, I'll be plotting my weight. So this one here is going to be the vertical axis. So this is the vertical. Let me just put vertical here. Then the extension is going to be on the horizontal axis. So this is going to be on the horizontal axis. So let me now go into the plotting of the graph. Okay, so having my graph, let me open this graph sheet here like this. So first thing for me to do is to take my origin. Okay, so let me just take my origin here. Let me just take my origin here and take my origin here. So then let me take my this origin here too. Okay, so after having this, then what do I do next? Like I said in my alternative A, I like putting something, this arrow here. You name here your y-axis, as you can see clearly here. Then you will name here your x-axis. So let me label the graph. They said from here we were being told that this one should be the vertical, this one should be the horizontal from here. So you know that your vertical is this side, whereby your horizontal is this side. So for the vertical, which is for this side, now this is going to be weight in n. So this will be the weight. Okay, I can just write ordinary n. Let me just put ordinary n. That's the new thing. And for this one is going to be the horizontal. This is horizontal and that is cm. So the unit is okay for it like that. So now for my readings now, okay, let me deal with the vertical axis first. The vertical axis is your y-axis, while your horizontal axis is your x-axis. So from this reading now, I have 1.5 to 2.53, 3.5. Good. I can actually make it if 2 centimeter represents a 0.5 unit, that should work for it. So let me measure 2 centimeter here for me to show you. So looking at this ruler now, so if I should measure this, so 2 centimeter is from here to here. I hope you can see. So this is 2 centimeter. You know, I've taken my origin from here. So let me put my ruler here. So my 2 centimeter is from here to here, from this place to this place. Okay, so if I should put 0.5, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, that's good for this graph. So from here now I have here should be 0.5. If here is 0, here should now be 1.0. Okay, let me put 1.0. Here will now be 1.50. Then here will be 2.00, whereby here will be 2.50. Then here will be 3.00, and here will be 3.50, and then this next one will be 4.00, and here will be 4.50. So as you can see, 4.50. So I have this like that. Then okay, let me take my scale. Let me write my scale here. So scale now for the x-axis, and then for the y-axis. Now for my y-axis, now this is my y-axis. My y-axis I'm taking is 2 centimeter representing 0.5. 2 centimeter representing 0.5 units. So that is the scale for my y-axis. Now remaining my x-axis. Now for the x-axis here, let's look at this extension. No, this is the horizontal. The extension is horizontal. So I have 4 to 10. So the best thing for me to do is to use 1 centimeter. Let me see. If I have here as my the maximum number I have here is 10, and the minimum here is 4. So if I have here as 1, 2, 3, 4, 5, 6, 7, 8. That is very small. So but to make my work easier, since I needed 4, like this thing started from 4, so let me just take it from here. As that means this thing is not starting from 0. My 0 is not here. So this is 0 is only for this y-axis. Why I won't put any other 0 here, because I'm not starting from 0 here. So yeah, I'm going to start from 4 here. This will be 4, 5, 6, 7, 8, 9, 10. Good. So it's good for me to start my 4 from here. Yeah, to start 4 from that particular place. So please don't put 0 here, because this place will represent 3. You understand? This place will represent 3 like this, but you don't need the 3. From what we have here, you don't need the 3. So let me just start from 4.0 here. Then here will now be 5.0. Here will be 6.0. Here will be 7.0, 8.0, then 9.0, and here is 10.0. So as you can see, so the scale, it will now be 2 centimeter. If you measure here is 2 centimeter, representing 1 unit. Yeah, because from here to here is okay, I said here is 3. If here is 3, from here to here is 1, here to here 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 1. So the interval between the scale is like the interval between all these numbers is just 1. So the scale will now be, for the x-axis is going to be 2 centimeter representing 1 unit. So 2 centimeter representing 1 unit. Now let's go to the plotting. So for this, when I have here as 1.5, here is 4.0. So 1.5 here, and then here is 4.0. So this place will be asterisk like this. So let me circle it. Now for another one, so I've done this, I've done this. So where here is 2, this is 5.5. Where here is 2, this is what, 5.5. 5.5 is in between. So I have it here like this. I've circled it. The next one, I've done this, I've done this. When here is 2.5, here is 7. So here is 2.5, and here is what, 7. So 7 will be coming from here, 7 will be coming from here, and then 2.5 is here. So they are meeting here, so they will be meeting here. So I have that. Then the next one here is I've done this, I've also done this. The next one is 3.00 and 8.5. So 3.00 is here, and then 8.5 is in between this 8 and 9, as you can see. So I will have it here like this, as you can see, 8.5 here. If you trace it, that will be exactly on this spot. Okay, as you can see, it's 8.5 to 3.0. So I've done this, I've done this, and the last one is 3.50 to what, 10.00. So 3.50 is here and 10.00 is here. So this is going to land here like this. So the graph goes like this. So now let's take the line of best fit. So let's take the line of best fit for this particular graph. So the line of best fit, for this particular graph is going to be from, my 8 points, this fourth one, this 3.00 and 8.50. I made a mistake here. So this is on, if you trace this particular one, this is on 8. It is on 8 and not 8.5. So let me clean it up. Sorry for that. So it has been cleaned, whereby the 8.5 is going to start from this in between, and then it's going to be here. So it will be here. So that's how the graph will look like. Now let's take the line of best fit. So taking the line of best fit, then it is a straight line graph. So the graph looks like this. So the graph looks like this. So I think I've answered this question here. They said plots a graph of weight n, that's Newton, on the vertical axis and extension cm on the horizontal axis. So you have done that. And then the next question here now says that we should determine the slope of the graph and state its physical means. So now let's determine the slope. The slope to be, let me take my slope from here. So the slope, let me take it from here to this place. So let me take the slope here. So the slope will now be, let me use as s will be equals to the change in n all over change in cm. So change in n all over change in cm. So the slope will now be equals to you can just write it as n2 minus n1 over cm2 minus cm1. Something related to like y2 minus y1 all over x2 minus x1. Yeah. So now let me name here as my n2 cm2, and here is n1 cm1. So finally the slope will be my n2, that's 3.00 minus my n1 is 2.00 all over my cm2, CM2 here is 8.5 minus my CM1 is 5.5. So if I should subtract that, my slope will be, that will be 1/3, and that will be 0.3. 1/3. This minus 2 is 1, and this, so 1/3, that should be 0.33333. And what is the unit? Newton per cm. So that's the unit. Newton per what? Per cm. That's the unit. So the next question now says, and state its physical means. Since our slope is 0.333 Newton per cm. Now what's the meaning of this and state its physical means? That is, what does the slope mean? What does this slope mean? So what I need to write from that, should, in case you are given that, he will say slope is equals to force over extension. Force over extension. So as you can see, weight, force in Newton, where is it? That's the n all over what? Extension from the graph. As you can see it here. So n is the force, we call it weight. Then the cm is the extension, as you can see it here. So since the slope equals to force over extension, so you can actually call the slope as k. You see, you can actually call the slope as k. So you now say, therefore slope will be equals to what? Spring constant. So that's just the meaning. So therefore the slope will be equals to what? Spring constant. So that's the meaning. So, and what is the unit? The unit is in as I've said here, Newton per cm. That's the unit, is in Newton per cm. It's for the age. And then if you're asked to state the I, now what is the significance of the straight line nature of the graph? So that one just means that the straight line graph shows that the straight line graph shows that the straight line graph shows that, so the straight line shows that Hooke's law is obeyed. Yeah, says that Hooke's law is obeyed. Hooke's law is obeyed. So which means that extension is directly proportional to what? To force. That's just the meaning. So Hooke's law is obeyed. Then which means that extension is directly proportional to force. So meaning that extension is directly, you can just put okay, let me write in full. Extension is directly proportional, proportional to force. It's directly proportional to force, meaning that when extension increases, the force also increases. That's the meaning of that from this graph here. Now you can see when extension increases, the force also increases. When you can see, as extension is increasing, the force is also increasing. That's the meaning of what is the significance of the straight line nature of the graph. So that's just the meaning that when the extension is increasing, the force is also increasing, so all the weight is also increasing too. So that's the meaning of this graph. So this is just like an idea for you to have. Basically, in most schools, your teacher will actually give you a table for you to work with. So work with the table your teacher gives to you, and also plot your graph very well. Follow this procedure to plot your graph. It's very simple. Then this is the exactly specimen for your question number 1. So if you need question number 3, I won't be working on question number 2. If you need question number 3, please just comment question 3 under the comment section, and I'll give you the link for question 3. Thank you so much. Wish you best of luck in your exam. Bye.